we have basically two new equations, both involving momentum, not including the equation for momentum, but rather how to use momentum. And one is conservation of momentum, the other is the force of impact equation. So we have the something that's momentum equals some of the final momentums, where momentum, of course, is vector. We also have the force of impact equation. Now, the first thing I want to make sure you understand is, when do we use conservation of linear momentum? Sandra, when is that first equation true?
When there's a collision and explosion.
During all collisions and explosions is when conservation of momentum is true. A lot of people think that this is only true when there's no friction. That is actually incorrect. Just because there's friction doesn't mean momentum is not conserved. All it means is that things are being slowed down before and after the collision, but still, during the collision, you have conservation of momentum. Now, there is a major difference between these two equations and when you use them and what they mean. This top equation, of course, you're talking about the mass and velocity, but in this bottom equation, you're also talking about mass and velocity. You also have time and you have force. But there's more to it than that. If you look at the top equation you can only use when you have multiple objects. Conservation of momentum really has to do with the interaction between two or more objects and what happens to the velocities during that event. Whereas the net force equals change in momentum over change in time is the force acting on one object. For example, I stepped off the desk. We figured out the force of impact on Mr. Palmer while he was colliding with the floor. Yeah, there are two objects involved there, but you're just figuring out the force of impact on Mr. Palmer. We also had in the worksheet, you had a volleyball being hit by a person. So that was the force acting on that one object, which is the volleyball. So there's a major difference between these two equations in that for the second one, the force, really you're just talking about the force acting on one singular object. We also had conservation of mechanical energy, which is mechanical energy initial equals mechanical energy final. When is this equation true? Julia? So this is the equation that you can use whenever there's no friction. Energy is conserved when there's no friction. Momentum is conserved during all collisions and explosions. If there is friction, you use the equation work due to friction equals a change in mechanical energy. Now notice, in this equation we have initial and final. We also have that initial and final in the work equation, work due to friction equation, and those are initial and final mechanical energies. Whenever you use these two equations having to do with energy, before you can use them, you first need to do what?
Determine if there's friction.
Well, that would be determining which one you're going to use, but in order to use the equation.
Oh, draw a free body diagram?
Actually, it's not the free body diagram. That's okay. Julianne.
Initial and final point.
And
Zero line.
you have to identify your initial and final points in the zero line. Now, we have initial and final points in both of these equations. And yet, I've never said you have to identify your initial and final points in your conservation of momentum equation or your net force equals change in momentum over change in time equation. And the reason for that is very simple. Because the initial and final points are always the same. The initial point is always at the start of the collision or explosion. And the final point is always at the end of the collision. So unlike conservation of energy or work due to friction equals change in mechanical energy, unlike energy, where you could talk about the initial energy, the final energy, you could talk about the energy at all sorts of different points. Really, with conservation of momentum and then change of momentum over change in time, you're always talking about the initial is at the beginning of the collision and the final is right at the end of the collision. That's why you don't have to identify.